Okay, so now I'm going to teach you exponential expressions where you need to simplify. I'm very much excited to be taking you through this topic, but most importantly, you need to make sure that before you attend this session, it could be after, just make sure to revise the basic laws of exponents, because what I'm going to be doing now, it is to actually apply all that I taught you regarding the laws of exponents. It is actually those basic ones. So maybe straight away, let me look into the first example. Let's say, maybe let me regard this as example A, where you may be given, let's say, 16 squared. I'm curious to know if I'm going to have enough space. I think it's fine. Otherwise, if not, I'll just add a new page. I will just see how it's going to work out, unless if I try to zoom in, and then after zooming in I might be having some space. Yes, I think what I will need to do is just to zoom in, just so that I can maximize on the available space. So let's see if I do that, and let me do that, maybe reduce that to that. Okay, let's see, example A, let's say we have 16 squared, where we multiply. Remember that dot, it simply refers to a multiply, even the brackets refers to a multiply, and lastly the normal multiplication sign that you know. So those are three ways that you can multiply. Then let's say we have 2 to the exponent of 7, multiplying 2 to the exponent of 5, multiplying 81. So the reason why I'm never intimidated by this type of expressions is because it's like they take 2, and then elsewhere they take 4, maybe somewhere they take 9, then they combine them together to form something like, let's say, 2 multiplying 4, and then they can just say over 9. So what I know is that 2 is to the exponent of 1, 4 can be written as 2 to the exponent of 2, which means there already we have 2 to the exponent of 2, and then 9, we know very well that it can be written as 3 squared, so that means this is the same as 3 squared. So that's how I always look at it, so that it doesn't look intimidating. So I'm therefore going to take you through this specific one. So remember, I'm saying this is an expression because you look at it, it doesn't have an equal sign. That is why it is an expression and not an equation. If it had an equal sign, it would be an equation. So since it does not have an equal sign, it means you are going to simplify. So the question now is, how are you going to simplify? You start with that base of 16. So the base of 16, let's see, what is 16 in a form of a base and an exponent? I think, let's see, is it not 2 to the exponent of 3? Nope, 2 to the exponent of 3 is 8. Let's see, what about 2 to the exponent of 4? Yes, it gives 16. So that means what you do, it is to rewrite that 16 as 2 to the exponent of 4. Everything else stays where it is, exactly as it is. And then now I think, based on that law where we said if you are having a base, maybe to the exponent of x raised to another power, this is the same as you taking that base and you multiply those exponents. It is the same law that I'm going to apply here, where I'm having that 3 and then it is that 2 that multiplies the 4. So can you see I've applied that law? And then here it looks like already I'm having 2 and then 2 there as the base. Why can't I apply that law which says if you have a base to the exponent of x and it's being multiplied by the same base to the exponent of y. Why can't you add their exponents? Instead of you writing a b and another b, write one b, and then if those bases are multiplying each other, add their exponents. So you see there the base is 2. I'm no longer going to write 2 of them, but I'll just write 1, and then I will take those exponents and add them together. Then this one of a big base being 81, we need to rewrite it in a form of a base and an exponent. So what is 81? Let's see, is it 2 maybe to the exponent of 5? Let's see, 2 to the exponent of 5, 2 to the exponent of 5, nope. 2 to the exponent of 7, nope, it's too much. 2 to the exponent of 6, nope, it doesn't work out. Maybe let's try 3 to the exponent of 4. Oh yes, it works out with 3 to the exponent of 4. So I've done it the manual way. There's another way in which you can easily do it on your calculator. I think you just punch 81, then you say equal sign or equals to, then it will give you 81. I think you click on shift, then you look for a button which is clicked which is written fact or FACT, fact, yes. Then it should give you 3 to the exponent of 4. But otherwise, worry not, I will definitely show you in terms of how you do it. Okay, then it's fine. So you will therefore say this is equals to. It now becomes easier because you've worked on it nicely. What you just need to do again, you see, there you apply that same law where you need to multiply. So it's like you are having that 2 to the exponent of 4 has to multiply that 2. What will that be? I think when you multiply those 2, definitely it will be 8. And then you are having 3 to the exponent of that times that, definitely that is 8. Over, and then you are having 2 to the exponent of what is 7 plus 5? It should be 12, multiplying 3 to the exponent of 4. So all that you were doing, it was just to simplify or work out those exponents. So now the next thing that we need to do, very much important, if you remember, I said when you have a base to the exponent of, let's say, 8 over the same base, only if it is the same base, and then you have, let's say, to the exponent of 4. I said the smaller exponent visits the bigger exponent. That's how it works. So that means it is this small exponent that has to visit the bigger exponent, which means this exponent has to go to the top, and it ends up being b to the exponent of 8. Remember, you minus when you are dividing the same bases. Then it ends up being base to the exponent of 4, because 8 minus 4, it is 4. But in a situation where you have base to the exponent of 4 over base to the exponent of 8, remember that base, it doesn't matter what letter it is, it doesn't matter what number it is, as long as they are the same. So in this case, it means this 4 has to go to the denominator part. The statement remains, the smaller exponent will always visit the bigger exponent, which means in this case, you end up having 1 at the top over b to the exponent of that bigger exponent, you minus the smaller exponent. So that means in the end, it ends up being 1 over b to the exponent of 4, because 8 minus 4, it is 4. One may be wondering to say, where does that 1 come from? Remember, you have an invisible 1 there. So that's where that 1 is coming from. If you had 4b to the exponent of 4, that means there you are going to have 4. So in short, what remains, it is the coefficient that remains at the top. So let's now try to apply that. So that means this 8 will have to go to the denominator, where it minus that 12. And then this 4 will have to go to the top. In other words, it is 3 to the exponent of 8 that remains at the top, where you will need to minus that exponent of 4 from that 3. And then you will say over, it is 2 to the exponent of 12. You will need to minus that 8, because 8, it is the smaller exponent. You therefore end up having 3 to the exponent of, what is 8 minus 4? Definitely that is 4, over what is 2 to the exponent of 12 minus 8. Is it 4? I think it is 4. So, finally, it looks like you end up having your final answer 3 to the exponent of 4, that is 81. I've just done it not long ago. And then 2 to the exponent of 4, definitely that is 16. So that means this is the end of it. So can you see, it's like you had different types of it's like you had different types of expressions or small expressions which were combined together to form a math problem, being that type of an expression that you had to work out. So I think that made sense. Maybe let me now jump onto the next one. You might as well take a screenshot so that when you do your short test, at least in case if you need to come back to this, you will then be able to redo this same thing that I've done before you attempt another problem which may be similar to this. So let me just add a blank page there. Let me just remember to zoom in, just so that at least I will be able to. Okay, I zoomed in too much, but otherwise it's fine. Okay, so let's say, maybe let's consider this to be example B, whereby for example B, let's say we are having in the brackets, let's say 2 to the exponent of x, then we close that to the exponent of 4, and then we multiply this by 9 to the exponent of x, and then we divide the whole of this by 12 to the exponent of 2x. So this is what you are given. Again, it is an expression because we don't see an equal sign, which means we are going to simplify. Then not only that, just think of it as you are given each of those but combined together. So what I know is that on that first part, I will apply that law which says when you have the base raised to a base and raised to another, not raised to a base, but a base raised to an exponent, and you have another exponent, you just multiply those exponents. So in short, I'm saying you have 2 to the exponent of that invisible 1x multiplying 4. So the 4 will multiply the 1. 4 times 1, definitely that is 4, and then because there's a letter there, you just write it as it is. Then this is multiplying 9. When it comes to 9, definitely 9, it should be 3 squared. So can you see, I'm doing that inside the brackets because I'm only changing the 9. So that's why you need to rewrite it or write it inside the brackets. Then you will easily work it out. And then when it comes to 12, you might need to remember that 12 may not be written as something raised to the power of something, but definitely if you do that way of saying you punch 12, then you press equal sign, you click on shift, then you click on that button which is written FACT, fact, I think, yes. Then you say equals to, you might find that it gives you 4 multiplied by 3. So that is how you can expand that 12. Obviously, it is to the exponent of 2x. So be careful and be considerate of how I've done it. It is 4 times 3, which is equals to 12, because it cannot be written as something being the base raised to whatever. So now let's see. In terms of the next step, you just keep on doing what you can do. So this base of 2, we can no longer further simplify it. It just remains as that as its smallest base. Then here you apply that law which says that times that, which means you end up having 3 to the exponent of 2x. And then this is being divided by, very much important, be careful when it comes to this one. So you have a base, which is a, and then another base being b. The reason why I'm saying a and b is just to show you that these bases are not the same. You've got 4 and you've got 3. 3 and 4 are not the same. That's why even with the letters, I'm using different letters. Therefore, if you are having whatever there, then this exponent, it will multiply the exponent of that base and again the exponent of that base, of which in this case will be invisible 1, invisible 1. So in other words, I'm simply saying you have 4 to the exponent of that invisible 1 multiplying 2x, that invisible 1 multiplying 2x, which means you have 4 to the exponent of 2x, because 1 times anything is the same as anything. Again, you are having that 3 where you are having that 2x. So you see, I've changed from that multiplication sign of cross to the one for the dot, because it is easier to deal with the one where you have a dot. Now let's see. So, notice something very much important. 4 can be written as 2 to the exponent of something. So, same time, I can modify, I'm just trying to save time, but on your next step, that means you can still rewrite that 4 as 2 to the exponent of 2. Everything else remains the same. I'm just doing that to save space and time. And then that means your next step would still be 2 to the exponent of 4x. Everything remains the same until everything is in its lowest base. So you see now that law again, it repeats itself. 2 times 2, it ends up being what? 4x, where you have that 3 to the exponent of 2x. I hope you are following what I'm doing there. And let's see, where do we go now? Why does it look like this will cancel with that and that will cancel with that? The moment things cancel out, then you just remain with 1. So that's how you end up having 1. Or otherwise, if you did not want to do it that way of cancelling, you can still say you have 2 to the exponent of that 4x, where you minus that 4x, multiplying that 3 to x, where you minus that 2x. So in this case, it doesn't matter which one visits which one, because they are equal. So if they are equal, let's just make a conclusion to say the denominator will always visit the numerator. Yes, let's maybe conclude it in that way. So can you see, we end up having 2 to the exponent. What is that minus that? Definitely 0 times. What is that minus that? Definitely it is 0. So you end up having 2 to the exponent of 1. We set anything to the exponent of 0, it's 1. Yes, I meant to say 2 to the exponent of 0, it's 1, multiplying 3 to the exponent of 0 being 1. 1 times 1, it's equals to 1. And that's how you work it out. I hope that makes sense. Maybe very quickly, let us now look at this example. Just want to zoom in there so that I've got enough space. Okay, then it's fine. Let's maybe look at this example, where this is example C, and let us say for this example C, you are given 16 to the exponent of x, where we minus 1, and that is being divided by, let's say, 2 to the exponent of 4x, where this is multiplying 32. Where are we going to start? A big question. So my advice is that you always start where you have the bigger bases, so that 16 you can try and rewrite it as something. We already know that 16 now is 2 to the exponent of 4. Everything else, you will rewrite it exactly as it is. So it mustn't be that you've changed something and then the x or the 1 or the negative disappears. It must just remain as it is. Then from there, you jump onto that part of the denominator where it looks like that 2 to the exponent of 4x. There's nothing that you can do there because it is in its smallest base. But the question now is, what about 32? I think 32 can be written as 2 to the exponent of 5. You can just check it, but if I remember, this is what 32 is. So now can you see, you have each expression in its simplest base or in its smallest base. Now that you've done that, all that you need to do is to apply the law. So remember, if you have a base to the exponent of 2, let's say an example, and then you may be having x plus maybe let's say 2. The law says this exponent will multiply each of those. It will multiply that, and again it will multiply that. So it's like you are having 2 that you need to multiply it by that. So you will definitely have to say that times that, that times that. That's what I'm going to do there, where I'm having the base of 2, and then that 4 multiplies that, it also multiplies that. That's why I end up having 4x, where I minus 4, because 4 times 1, it is 4. Okay, and then what else do I have? I still have my 2 to the exponent of a 4x, but wait, this and that are the same basis, so that means I can just plus that. The reason I'm plussing is because I'm having the same basis. What do you do when you have the same basis? You add their exponents. So now in a situation where you are not sure in terms of which exponent is bigger, which exponent is smaller, which exponent has to visit which one, do not worry that much. If you are in that situation, always take the denominator and make it visit the make it visit the numerator. Then once you've done that, if you still end up having a negative exponent, I will then show you how you rewrite it as a positive exponent. So that means in this case, you can just say, already you are having 2 to the exponent of 4x minus 4. Then you just take this exponent, you take it to the top, it changes the sign from being positive 4x to minus 4x. You do the same for that one, it goes up, it changes the sign to become minus 5. So that's how you would have to work it out. I'm just trying to check something here. Yes, okay, this looks fine, then it's fine. Let's see. I was just trying to verify if I did not make any mistake, of which I believe that I did not. Okay, then it's fine. So you look at 4x, which will minus 4x. So you end up having that 4x cancelling with that. It's like 4 minus 4 is 0. Then you end up having 2 to the exponent of what is negative 4 minus 5. Yes, I almost said 4. Negative 4 minus 5, definitely that will be negative 9. So you see, now you have it as a positive exponent. You always don't want to have your final answer as a positive exponent. You will therefore have to rewrite it such that you have that invisible one there, which is the one that remains at the top, and then this one, you rewrite it there as 2 to the exponent of 9. You see, now you are having it as a positive exponent. So that's how you would have it as a positive exponent. One can still go further to say it's the same as 1 over 512. I don't know why here on the example that I'm having, their final answer is 2, of which I'm suspecting that is wrong, because when they were minusing the exponents, they ended up having 2 to the exponent of 4x minusing 4, and then they said into, not into, but minusing that denominator. So here, instead of a plus, they put a minus there. I think that's why, because they will end up having 4, not just 4, but not just x, but 4. They'll end up having this, and then that. This will be minus 4x, and that will be positive 5, where that cancels with that, and then it's like 5 minus 4, it is that invisible one. So I think that's where they made a mistake on that one, but it's fine. Let's see. I want to actually verify if indeed what I've done is correct. So I'm just going to use my tactics to prove if what I've done is correct. So how you do it, you can substitute any value that you like in place of x. Maybe let's put 2 and not a big one. So that means you'll say fraction 16 to the exponent of 2 minus 1. Where you see x, you put 2. Then at the bottom it will be 2 to the exponent of 4 into 2, because where I see x, I put 2. Then that multiplies, let's see, that multiplies by 32. When I say it's equals to, it must give me that final answer being 1 over 512. Yes, it does. So that means what I've done is correct. They definitely made a mistake, and luckily I was able to detect the mistake. So if you want to prove whether your final answer is wrong or correct, it doesn't matter which value you use. Myself, I chose to substitute 2 in the original expression. You can choose 3, you can choose 1, you can choose any number that you like, as long as you won't choose one that will give you an error. If it gives you an error, then try a different value, just so that when you say it's equals to, you compare with your final answer and check if it gives you the same final answer. So take a screenshot of this. I think you might need it. And then let's see. I want to go back to allow you to take a screenshot of this. And once you've done that, I'll go back so that you can take a screenshot of this one. So I think by now you should be ready to try and attempt your short test. I'll do this for the last time so that you can quickly take a screenshot in case if I caught you off guard. Okay, that was the sound of the screenshot. I could hear you taking a screenshot, and then here's the last one. Let's see. Let me do that. Okay, then it's fine. Good luck, honorable member. We'll see if you are going to manage or not. I think